In this video, we're going to talk more about an idea than a specific way to code, but it's a really important idea, and it influences the behavior of variables, depending on whether they're a basic data type like an integer or a double, or an object like our student object that we've been using. So let's look at our code here. We've got a really simple main method. I create an int I called a just to give it a name. I set it to 1. Then I call a method called add1 and I give it the value for a. And then when I'm done, I print out the value of a. The add1 method takes the number and adds 1 to it. Doesn't do anything else. So I want you to look at this for a minute and think about what is going to get displayed on the screen when I run this. What is a going to be here at the end of the main method? Do you have a guess? Let's give it a try. And it's giving us a value of 1. A is equal to 1. And that might have been counterintuitive. You might have guessed that, but you probably guessed 2. And that's reasonable because it seems like our add1 method should change the value of a. It's adding 1 to its variable, which was a. We passed it the value of a. So let's look at what's really happening behind the scenes. When we start a method, the main method or any other method, what happens is Java creates a little place in memory for the variables in that method to go. So when we say something like int a equals 1, we've got a space for that variable. That's an integer, it's got the value of 1. When we call another method, we create space for that method. So we'll add a little space in memory for the add1 method. Init has a variable called num. And num gets the value of 1 because when we called add1, we gave it the value 1. So we put 1 in that space for memory. But you'll notice those are two different variables in two different places in memory. So when we add 1 to num, it becomes 2, but a is not changed. They are totally different variables. They just happen to start with the same value because we passed a to the add1 method. When we're done with the add1 method, that space in memory actually disappears. And then we print it out. We print out a still has a value of 1. This part of memory is called the stack, and we'll see in a little bit a second part of memory called the heap. But the stack behaves just like that. When we call a new method, we create space in this stack, in this part of memory, and we create just enough space for all the variables that method will need. Now let's go back to Java and look at almost the identical code, but our variable a is not an int anymore, it's a student. So it's the same student class we've been using. I created a student, just first name test, last name student, major of history, and a GPA of 1. And then I call the add1 to GPA method. That gets a student. It adds 1 to its GPA. So it gets the old GPA, adds 1, and it sets the new GPA. And then we print out the GPA of that student. So the old version of this program essentially would print 1 when we were done. This version with a student object actually prints 2. So in this case, our add1 method changed our variable a. It did not leave it the same like it did before when it was an int. So what's the difference? Let's again take a look at this in action. So here's the baseline of our new program. What's new is I'm going to draw the heap up at the top. The heap is a different part of memory, and that's a part of memory where objects go. So basic variables like integers go in the stack. Objects go in the heap. Let's see how this works. So just like before, when our main method starts, we create space in the stack for our main method and its variables. Student A equals new student. What that does, it creates a new student called test student with a GPA of 1 up in the heap, and I just randomly pick spot 1,000,000 in the heap. And what we'll do now is we'll put in main our variable a and a reference. We just remember where is that variable that I was referring to. It's at spot 1,000,000. So you can picture it's almost like an arrow. It's pointing to or referring to that spot in the heap where the information is actually stored. When we call our add1 to GPA method, we call down here, we create a new space in the heap for our add1 to GPA, and we're passing in the student. We're not passing in the information, we're actually passing in the reference. So student gets a reference. It also remembers my student is at spot 1,000,000 in the heap. We're following student.setGPA, says go to spot 1,000,000 in the heap and change the GPA to 2. When we're all done with our add1 to GPA method, that gets taken off the stack, but the change on the heap is still up there. That doesn't impact the heap at all. So when we print a.getGPA, A says go to spot 1 million to get the GPA. We go up there and the GPA is 2. We display 2 on the screen. So this is the big difference. All objects, anytime we write equals new and so on, new student, new scanner, new anything like that, we're creating an object up in the heap. Our variable is only remembering where that object is. And so when we interact with it, we're actually interacting with that information up in the heap. If we say student B equals A, all we're doing is B is now pointing to the same spot in the heap that A was. So if we change B's GPA, when we get it from A, it has the new GPA. They're both referring to the same location in the heap. Let's look at one more variation in this code. What if in our add1 to GPA, instead of saying student.setGPA, we say student equals new student and whatever information with a GPA of 2. So when we run our program, again, we create a space in the stack for main, and then we create a new student. We create that information up in the heap, and down in our stack, we remember where it is. So A is now referring to spot 1 million in the heap. Add1 to GPA, so we create a space in the stack for add1 to GPA, and we give it a student variable. It's referring to spot 1 million as well, because we passed along A to our add1 to GPA method. But now we don't say student.setGPA, we say student equals new student. So what that does, whenever we see a new, we're creating a new object. We're creating a new object up in the heap, a test student with GPA of 2, and we're setting student equal to that. So student is now pointing to spot 1.1 million, not 1 million anymore. So the thing at spot 1 million hasn't changed at all. There's a new thing with new information at spot 1.1 million. So when we go back to our main method, so we remove add1 to GPA from the stack, and A is still pointing to our original test student with a GPA of 1. So when we call a.getGPA, we get a GPA of 1 and print it on the screen. One last note, you'll notice that nobody is referring to that test student at spot 1.1 million. Java will actually notice that it's not in use anymore, and clean it out so that we can use that memory again. That's called garbage collection. It's a really handy feature of Java. Not all languages have that, but it makes it much easier for us that Java handles that automatically. It might clean out that space immediately. It might wait for much later into the program, but it will do it at some point, and it will allow us to reuse that memory. So to quickly summarize, we've got 2 locations in memory, the stack and the heap. What goes in the stack? Basic data types like an int, a char, and a double. By default, when I call a method and I pass an int, or I do something like int a equals b, I'm passing the value of b to the variable of a, I'm just passing the value. I'm passing the number 5, and I'm not passing a reference. If I change one of the variables, it doesn't influence the value of the other variable. So by default, basic data types are all passed by value. There's a way to get them to be passed by reference, but we'll skip that for this course. If you pass it in a method, it's going to be just passing the value. So what goes in the heap? Objects. Things like student or scanner. If I say student A equals B, I'm not copying the values of that student over. I'm copying the reference. If I make a change to A, I'll see that change when I access the information in B. Or if I call a method and pass a student, I'm passing the reference. If I make a change in that method to the student, I will see that from my original method. Same thing with a scanner. If I read in information from the keyboard, that influences the next time I read in information, even if it's from a different method. Because this difference is so important, that's why we name our variable types differently. So a basic data type has a lowercase letter to start it. And a class always starts with a capital letter. That's to help us really quickly distinguish when we're looking at the type of a variable. Is this a basic data type or is this a class? Will it be on the stack or will it be on the heap? You'll notice I've left one thing out. I haven't talked about strings. And in fact, there are sort of similar ideas to a string called an integer and a double with capital letters. You can tell capital letters, capital S for string, capital I, capital D, those are objects. They live on the heap. So they belong on the heap. They behave like objects, but they're a little unusual. They're what's called immutable. They won't change. So there's no set method for a string. You'll notice anytime we call string dot to lowercase, or string.toUppercase or string.substring, it gives us a new string back. We don't change our variable, we just get a new string with a new value. So these live on the heap, they behave just like objects do, but sometimes they behave a little bit surprisingly because we can't change them. When I pass a reference to a string, I'm not going to change that string in the other method. It's just impossible to do. A string cannot be changed. And our capital I integer, our capital D double behave in the same way. They can store an integer and a double, they behave like objects, but they can't be changed. And so in some ways, passing them by reference really behaves almost exactly to if we pass them by value.